project, we decided to build a sound effects generator circuit. The ultimate goal of which would be able to create a very easily controllable variable that would allow us to create a wide range of warbling sound effects.
How's it work?
Well, the 555 timing chips regulate the charge accumulated by the capacitors as voltage is put through them. The 555 timing chip periodically reroutes the current in the circuit, allowing the capacitors to discharge them periodically. The frequency at which the capacitors accumulate and release charge is regulated by the resistance and capacitance of the circuit, which in turn is regulated by the individual resistance and capacitance elements inside the circuit. This accumulation and release of charge in the circuit effectively causes an oscillation of pulse frequency in the 555 timing chips. Figure 1 shows a diagram of our sound effects generator. R1 and C1 determine the frequency at which the 555, the first one on your left, oscillates. R7 and C3 determine the frequency at which the 555-2 on the right oscillates. Together, the beat frequency produced by these two oscillations creates sound effects through the 8-ohm speaker. Alright, cool. Let's see if this circuit works. So this is our sound effects generator circuit. So I just spoke a little bit about it, so now let's see it work in action. Casey, you have the honors. As you can see, the sound effects that are coming out of the speaker kind of sound like butt. How do we fix this, Casey?
Well, what we want to do is make a speaker that creates really annoying, warbly sound effects. So we're going to have to change something to fix this problem, because this obviously is a too low frequency sound emission.
So what's the plan?
Okay, in order to create higher frequency emission from our sound effects generator, we're going to replace C2 with a bigger capacitor, 100 microfarads, and we're going to replace R7 with a very small resistor, a light-sensitive resistor, and the way this works is the more light shining on it, the less resistance comes through here. When it's got a flashlight on it, it's about 5 ohms, and when it is completely covered in darkness, it's about 100 kilo ohms.
So as you can see, very well here, we were able to create a very annoying warbling sound, but that's okay because that's what we wanted to do in the first place. As I'm sure you could have seen there in the beginning case, if you want to be so kind as to demonstrate this, if we turn this on, because we mentioned before what the photoresistor does, changes the resistance based on the amount of light that the resistor sees. We can change the sound, we can change the resistance. So if you block the light that goes into the resistor, as such, you can create a different range of sounds. It's almost like an air piano, like that. Or it could be your own personal DJ, as Casey would like to say. Also, another thing that you may have noticed, is Casey, if you wanted to show them again, is when that sound is playing in a very, steady sound. If you change the voltage, you get these very. If you change the voltage, you get these different, very discrete sound effects, which is basically just the capacitor discharging. Like that. So now what I felt was the most natural thing to do after this was to figure out how to automate that system. So instead of us having to make a tune by just, thoughtlessly turning around that little knob, we would make a program on LabVIEW that would control this power supply and basically change this voltage out, and we can, make a song of that.
What you thought to do.
What we thought to do.
LabVIEW. What good is a sound effects generator if you can't even play a beat with it? Right?
I agree,
Right.
yes.
So, what I did is I made a LabVIEW program that will play a song through the power supply here, because this is the only thing that will give us up to 20 volt output. A lab jack won't do that, so we had to download a program right here, this little LabVIEW VI, that allows us to connect the computer directly to the power supply and output whatever voltage we want to our circuit, which is going to allow us to play a tune. The way I've done this is by selecting the GPIB address of the power supply, which in this case is 5, and then I took I simulated an arbitrary signal, which I can demo here for you. I actually made these X and Y values that are going to make a tune. It's going to go like doot 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 doot. And then I've also made another arbitrary signal. This first one is connected into the voltage input of the power supply. The second simulate arbitrary signal is millisecond time measurements that's through a merged signal connected to the iterations of the while loop and regulated by a wait timer. So it's going to cause these changes in voltage, i.e. these Y values, to wait the amount of time I have allotted for them in here before changing to the next voltage, which is going to give us a tune. And that's as simple as it gets. So here's the tune that we made up for Project 1. And we can be in our own personal DJ with a flashlight. Pretty sweet. So overall, after building our circuit, we learned a few things. We learned how to find the necessary LabVIEW components and use them to regulate the power supply flowing through the circuit, using only the computer. We also learned how to regulate a frequency and create a beat frequency with specific pitch by switching out certain resistors and capacitors. We used a photoresistor, and we learned how that works. The more light shining on the photoresistor, the less resistance overall it contains. Therefore, the more current can go through it. We also learned that the pulse frequency output of the 555 is most affected by current flowing into ports 7 and 2, and the overall output voltage flowing through the circuit. By adjusting and enhancing these three components, we can generate and manipulate sound over a very wide range of output frequencies.
Our plan for the immediate future includes working on an infrared security alarm that, upon removing an opaque block between the phototransistor and an infrared LED, will emit a very annoying blaring sound. Ideally, we want to be able to hook up our infrared security alarm to our sound effects generator that we just created, and it would be perfect if we could hook them up wirelessly, so we wouldn't have to put this huge electronic circuit attached to a door or window. We could instead put this very small security alarm attached to whatever opening we want to secure, and have that transmit a signal to this sound effects generator, and that would emit a very annoying blaring sound that we could, have a tune to it, so the intruder could, dance away as he tries to leave the premise.